Hi, everyone. My name is Raquel with adtmag.com, and I'd like to thank you all for joining us. The topic of today's webcast is Driving Service Ownership with Distributed Tracing, sponsored by Lightstep. Before we begin, I'd like to cover a few housekeeping details. There will be a Q&A session towards the end of today's presentation, so please type any questions that you may have in the Q&A box. Lightstep has also provided a resource which corresponds with today's webcast, so please take a moment to check that out. And additionally, this webcast is being recorded, so keep an eye out for a link in your email so you can rewatch this presentation or share it with a colleague. Now I will pass the time over to our speaker today, Daniel Spoonhauer, aka Spoons, who is the CTO and co-founder of Lightstep, to get us started. Over to you, Spoons.
Thanks. Yeah, I'm excited to be here to talk about service ownership today. But before I get started, just a little bit about myself. So I'm Spoons, that's what everybody calls me, and I'm the CTO and a co-founder at Lightstep. Lightstep provides simple observability for deep systems, observability with distributed tracing at its core. So I spend a lot of time there thinking about and working on service ownership and distributed tracing. Before I helped found Lightstep, I was an engineer at Google, where I worked as part of Google's cloud infrastructure and cloud platform teams. I worked closely with SRE to establish processes and tools to help enable service ownership. And finally, I also wrote the book on distributed tracing, which I'll talk a bit more about soon. Okay, to set some context, I wanted to talk a bit about this question: what changed? An important question, I think, for folks that work with production software systems, but specifically, what changed in the way that we work, right? Why is service ownership something that we should be talking about right now? The kinds of things that have changed, there's been a series of technical changes, right? The sorts of infrastructure that we used as we move from bare metal to virtual machines to containers, and finally to orchestration tools like Kubernetes. And each of these has provided new abstractions, right? New primitives that we can use to build systems, and of course, introducing additional complexity as well. And partly enabled by those technologies, we've moved to architectures like microservices or serverless that have also changed the way that we work. A lot of times, those hopefully have not only allowed you to scale your systems more quickly, but also allow your teams to work more independently. And speaking of teams, many organizations, Lightstep included, have adopted a lot of DevOps practices. And DevOps can mean a lot of different things. It could mean a culture of collaboration between developers and operators. It can mean things like blameless postmortems. It can also mean tools like CI/CD, or even using some of these things like Kubernetes or containers. But I think what's important in that is that we're connecting developers with their users, right? And all of that is good, but I think service ownership really is a way of making a bunch of pieces of that super concrete and bringing all of those responsibilities together with small groups of people, right? So let me go ahead and define service ownership. So this is really making application developer teams responsible for the delivery of software and the service. So that includes, not just things they were doing before, like writing code and fixing bugs, but things like incident response, right? Getting paged. It also includes understanding how much it costs to run that infrastructure, and maybe addressing that if it needs to be addressed, as well as things like capacity planning and thinking about the future and how much infrastructure they're going to need. And really, this is just taking responsibilities of the organization as a whole and just dividing them among the teams, right? So again, DevOps is great, and I think there's a lot of great practices in there, but I think of service ownership as a lot of ways the core and an important piece of that, but really making those responsibilities concrete. And if we do that, then hopefully we get some benefit, right? We've increased the independence of those teams, so they hopefully don't have to interact as much. Each of those teams can, again, work directly with their users, understand what's needed, write some new features, and push those out without necessarily having to consult with a lot of other teams and go through a lot of different reviews. And you also allow those teams to make more autonomous decisions, and that hopefully will lead to better outcomes, right? So if they decide that they want to move faster and release every day, then if that's something that their users want, great, they can get those outcomes as well. But there's some challenges that come along with this, obviously, as well. And to talk about those, I want to draw this picture. This is a feedback loop I'm going to show, and this goes for production software systems as well as a lot of other systems. on one half of that feedback loop, you've got control. These are the tools and processes that you use to effect changes in your production systems. That could be something like Kubernetes or associated tools. It could be a configuration management system. It might even be something like a service mesh. Again, these are all ways that you effect change, right? That you control these systems. And on the other half of the feedback loop, we've got the ability to observe. And so these are tools and processes that we use to understand what's happening in production. And these are, we've had tools to do this for a long time, even if we didn't call them observability tools, right? We've been able to understand what's happening. But I think that the innovation and the investment in the top half of this loop has really outpaced the innovation and investment in the bottom half. And I mean, there's reasons for that, I think. You can't you can't run software without some way of deploying it, right? But I think that often means that the way that we observe things often kind of takes a back seat. And that's problematic because it's like we've built this really fast car with a powerful engine, but no speedometer. And that means we can go really fast, but we have no idea how fast we're going. And I think more sort of adding complexity to that is that the control systems, like obviously we would like to have those uniform throughout our organization. But if different teams make slightly different choices there, it's probably okay, right? Like if one team wants to use some fancier features of Helm, like cool, go for it. But we really need the solutions, the tools that we use to observe our systems to take a holistic approach. They can't be team-by-team solutions. And these are really help, I think, to understand some of the obstacles to successful service ownership. Really, you can't have independence without clear goals and responsibilities, right? You can't delegate those responsibilities without defining what they are and without giving those folks a target. And you can't scale that. You can't scale that kind of autonomy without consistent ways of measuring and reporting on progress and outcomes. And I think this lack of innovation and investment on the way that we observe these systems has really, it gets in the way of that consistent measuring, right? Because we don't have this holistic picture of what's happening. And that means, as much as we say we'd like service ownership, it's just not happening. Okay, so what I'm going to talk about today, I'm going to talk about a couple of things. First, I want to be super clear. I said, accountability. Ownership really has two halves, I think. And a lot of folks, me for the beginning of this talk included, really talk about accountability as part of that. But I think agency is also super important, right? That's the ability to improve things, to make changes. And I think that goes a long way to reducing the friction when rolling out new responsibilities, right? Is to give folks the ability to improve the way that those things work. Effective ownership requires distributed tracing. I'm going to talk a bit more about distributed tracing in a second. But as I work through a bunch of different pieces of service ownership, distributed tracing is going to play a role in each of those. And those pieces that I want to focus on today are in three parts: documentation, on-call, and service level objectives. Okay, let me talk a bit about distributed tracing. Distributed tracing can mean a lot of different things. It can mean a tool. And I'm biased here, obviously, but different distributed tracing tools have pretty different feature sets. So even if you have one today, you might not be getting all of these features. And distributed tracing might not even be a tool, right? It might just be the data, right? This sort of telemetry that you're collecting in some way. So I want to kind of talk through some of these things just to make sure we're all on the same page. Okay, so let me start with some pictures. If you've used a distributed tracing tool, you might have seen something like this or like one of these. And they all have this kind of Gantt charty sort of feel, right? They show you how a particular request passes through your production systems. Just like a Gantt chart, time goes from left to right. And each of these colored blocks represents the work done by some service as part of handling that request. And the thing I want to emphasize, these are important, but these are really just the building blocks of what we can do with distributed tracing. Okay, let me use some words, not just pictures. Distributed tracing can be defined as follows. So traces are really a form of telemetry based upon spans and with some structure applied to those spans. So what's a span? A span is just a timed event that describes the work done by some single service. And I can kind of see my co-authors rolling their eyes a little bit at me. Not all distributed tracing requires that you use spans, but if you look at the way distributed tracing is deployed in industry today, almost all of those solutions use a span in some form. And sorry, the bullets in this are showing up as mailboxes. They're just bullets. I don't know why they're mailboxes. Right, so that's a span. But again, you can think of it as kind of a timed event. But But tracing, on the other hand, to kind of distinguish it from the data itself, is a tool that reveals how a set of services coordinate to handle individual requests. That might go not just for backend services, but include things like a mobile app or a database or some other piece of infrastructure as well. And that'll include metadata, either events, which you can also think of like logs, or other annotations like labels or tags. But one thing that my co-authors would definitely agree with me on here is that tracing always takes a request-centric view of application performance. So in a lot of ways, if you compare it to other kinds of telemetry or other ways of observing a system, those often take a much more service or host or container sort of point of view, right? And what we're doing here is kind of taking the whole thing and turning it on its side, rather than thinking about a particular service as the focal point. We're looking at the user's experience at that request, and then understanding secondarily how is that handled by each service, by each piece of infrastructure. Now, I said, it's just this span with this structure, and that structure is really important. So if you think about a trace, I've kind of added some more arrows here to understand that these arrows that go down in the trace, those represent calls, right? So that's where one service is calling out to another, and it's sort of handing responsibility over. And then the arrows that come back up represent returns. So traces encode the causal relationships between callers and callees. And that's key, because now you know where responsibility begins and ends, and then how to attribute things like failures to different parts of your application. I said that they're just the building block, right? Really, another way of saying that is that traces are just the raw material. They're not the finished product. So these traces, they're just structs, right? They're just data. It's a type, a data type that you use to communicate information between the application and a tool that provides distributed tracing, right? And that's the art and science of deriving value from those traces. If you want to learn more about traces, one places you can look is this paper that was put out by one of my co-authors and some other folks at Google, describing Dapper, which is Google's internal tracing system. This work was actually done more than 10 years ago now, but I think it has really influenced a lot of the open source work that's been done in distributed tracing. So it's a great way to understand that. And it also talks not only about how they built and deployed it, but some of the use cases. And one of the most important use cases there was understanding how different services contributed to the latency of web search. So when you think about going to Google and you type a search and you get all kinds of different results, not just results from the web, but you get news results and YouTube and images and product results, all kinds of things. And what this analysis would do is it would look at all of the requests that came to web search over the last week, and it would look at how each of those services had contributed to latency, which ones were on the critical path. And that information could then be used to prioritize work among those different teams. And that was really key, because otherwise a team could go off and do a whole bunch of optimization that was really good for the performance of that individual service, but might not have any impact on the overall performance as experienced by users. And you also, if you want to learn more, you can take a look at our book. The book covers everything about distributed tracing, from the very beginning of what it is and how to get started, to how to think about deploying distributed tracing and some of the trade-offs around cost, as well as how to get value from tracing, a bunch of very specific use cases, and where the future lies with distributed tracing. And all of the royalties from the book go to charity, so I encourage everyone to go and pick up a copy today. Okay, so let's talk about ownership now. As I said, there's going to be three pieces of this, and they're all going to kind of fit together in some way. The first is documentation, and really what I mean is, the point is to create some shared and written artifacts. And I know that's kind of the definition of documentation, but I think a lot of times, at least I think of documentation as sort of an after the fact thing, like, hey, let's go figure out a process and then document. Or, hey, we just built some new features, let's write the docs. And really, I think documentation, as far as service ownership goes, has to be much earlier in the process. And I'll talk a bit about that. I'm going to talk about on-call, obviously an important part of service ownership. And finally, I'm going to talk about service level objectives. Okay, to start with documentation. So the first step in moving towards service ownership is to create consistent and centralized documentation. As we grew at Lightstep, and as I'm sure a lot of your organizations have grown, you've looked to divide responsibilities. But before you can put those responsibilities up, you've got to know who the experts are, right? Because that expertise is going to serve as a basis for that division of responsibility, but the expertise itself is quite valuable, right? If you know who the experts are, that's something that you can actually communicate across the organization. That way, when a question comes up, others can find those experts as well. And documentation is obviously not just useful for finding experts. It's useful for finding other kinds of related information like telemetry or dashboards, for finding the definitions of alerts or playbooks that explain what to do when those alerts fire. And you can see I grabbed a screenshot of some of our internal Lightstep documentation for one of our services. And we use a template to do this in our wiki. And the template is really great. One is that it helps you create some consistency across the org. Everyone has an expectation for what they're supposed to be putting in the documentation. But the template also lets you extract information, right? It's providing some more structure there. And then you can do things like run reports, right? You can look across all of your services and say, where are the experts within my organization? How has expertise changed over time? And if you've centralized it, you can also do things like track last modified dates, right? And then you can report on that, and you can require teams to keep things up to date on some periodic basis. Even better than centralized documentation is to make that documentation machine readable. So again, I've grabbed kind of a clip here from part of Lightstep's internal documentation. So part of our documentation also lives in a YAML file, and that YAML file describes a bunch of things about the services, including which part of our organization owns them and some other key attributes of them. And once you've made it machine readable, that can actually eliminate a bunch of manual work that you have to do outside of the documentation, right? So you can use that, like we do, to generate dashboard configuration, to generate escalation policies, and you can even use it to generate the deployment pipeline configuration. So not only does that make it easy to create new services, but it makes the documentation necessary as part of the day-to-day work for developers. So the only way that a new service can get created at Lightstep is for it to be in this file, because you can't deploy it, right? There's no way to deploy a service that's not in this file. So we know that this file is actually always up to date, which is really important. In order for documentation to be used, in order for it to be valuable, it has to be up to date. And then finally, some parts of the documentation shouldn't be written by people, right? So sure, the owners, the experts, like absolutely a human should help keep that up to date. But one of the things that we struggled with at Google was keeping track of dependencies of services, what other services they depend on. And in that case, that's not something I think that you should try to have humans maintain. That's something that you want to derive from the application itself, from the telemetry that you're getting from that application. And this is sort of one of the places where distributed tracing can really help, because you can not only show the immediate dependencies of a service, but you can show the transitive dependencies as well. So whether that's 1 or 2, 3, or even more hops away. And so that will let you then make better decisions when you're thinking about architectural changes. If you're going to add a new dependency, you also can use it just to understand how time is being spent as a whole. And it's great for people who come onto your team and want to understand what's happening. But trying to keep this stuff up to date manually, it's just too hard. Okay, so documentation is important. It's first of all, in terms of service ownership, it's the record, right? It's the record of who's accountable. You're building a shared database of that ownership. It's also a way to automate a lot of mundane tasks, and that's great. That'll get people excited about keeping it up to date. And it's a way to train new team members. As I said, it's also a way to help for internal transfers, right? When you have folks moving between teams where their responsibilities in terms of service ownership will change, that documentation will play a big role. And the developers that I've worked with, I'm sure the developers that you've worked with as well, they really care about doing good work. They really care about the quality of their work. And when you hand them new responsibilities, they want to do a good job. And so one of the things that we found is having good documentation actually reduces the friction in rolling out service ownership, because it makes teams and individual developers more confident about those new responsibilities. It's sort of hard to overstate how much of a difference I've seen that make. But again, just building that confidence, letting them know that the information is there if they need it, if they get paged in the middle of the night, will really help move the process along. Speaking of getting paged in the middle of the night, one of the most stressful moments for a lot of engineers is being on call. And obviously on call is really important for service ownership. I think, when I talk with folks about service ownership, a lot of times the first thing and maybe the only thing that comes to their mind is on call. But in the organizations that I've worked in, on-call actually has often a lot of different responsibilities, not just about handling pages and incident response, but often they're responsible for communicating status, both internally within the organization and externally. They might be responsible for planned production changes. That might be deploying new code or just playing traffic cop to deploying new code or other infrastructure changes. And they might be responsible for a bunch of less urgent kinds of things as well, like monitoring dashboards and low urgency alerts. And in some organizations, they've actually even been responsible for other kinds of interrupt-driven work, like customer requests, basically because we figure, well, we can't really give them any story points anyway. They might get paged, and so why not just have them get interrupted all the time? And then finally, there's a bunch of communication that's really important being on call, right? Handing off responsibility to the next shift, making sure that they understand what's happened, as well as writing postmortems, which I'll talk about a bit more in a second. Okay, so making on-call better is important because that'll help, again, reduce friction in rolling out service ownership. And so, there's a couple ways that we can make on-call better. One of them is to reduce how much time it takes to respond, make sure that we can just do a better job of handling the alerts that we get. And the second one is to deliver alerts to the right teams. So, one way that we can make incident response faster, we can make responding to pages faster, is by making root cause analysis easier. And what we've done at Lightstep is actually take our pages. Here you can see one of them from our screenshot from PagerDuty here. And we've actually annotated them with distributed tracing data, right? So now you can jump directly from this page to a trace that shows what happened, right? So in this case, something was slow. Here's an example of a slow request. And this has helped our engineers just get to the root causes much more quickly. This is actually from one of our internal systems. Something was slow. Someone needed to figure out what happened. And in this case, I think there was some sharding that was not balanced, and one of the shards was much slower than the others. And this pointed them at that immediately, and they were able to take action quickly. That's great if you can help an individual respond better and give them the right information. Even better is to make sure you get the right individual. One of the teams I worked at Google, we sort of sat pretty high in the stack, and we depended on a lot of other services in order to handle requests. So we would often get paged, and we'd go kind of look through the logs and things, and discover that it was actually not our fault at all. It was just some other team that was whose service was being slow. And so we would turn around and page them. But, we're humans, right? We don't need to be routers as well. And so one of the things that's been done in the community, this was built and talked about by some folks at Zalando, including Luis Manera. And what they did was actually use distributed tracing data to dynamically route alerts. So they still alert on symptoms, as you should, of course. So in this case, their example, I'm sure not totally coincidentally, was an e-commerce platform. And so, checkout is a really important point in the experience for users. And so they alert on an increase in errors for checkout. But, they found that frequently it wasn't the checkout service that was actually at fault, that team couldn't actually take any action to mitigate the issue. And so what they would do is still alert at that same point, but then look at traces and, look at the checkout service and see what are the services that it depends on, and if any of those services returned errors. And again, look at those services and what they depend on, if any of those dependencies returned errors, and continue until they found a service that either didn't have any dependencies or didn't have any dependencies with errors. And then they would page that team. And they found that was much more likely to be a team that it could actually help mitigate the problem. Not always, but you're starting much closer to where action can actually be taken. And that can also just make engineers a lot happier, right? That they, are not going to get woken up just to route pages. They're getting woken up because they can actually take action to fix things. So that kind of brings me, to the last one, giving engineers and developers agency to improve it. This is really important. And part of service ownership, I think, has to be the ability to just say, hey, this alert doesn't matter for our service. It doesn't matter given the goals that we have. So we're just going to delete it. I wanted to say just a couple things about one other important part of being on call, and that's writing, sharing, and reviewing postmortems. Postmortems, I think, are how we improve on call, right? How we do better next time. And that both means making sure that we fix the root causes, right? So that, should those things happen again, that we've addressed them. But it also means improving our responses, because there's a lot of novel issues that will come up in the future, and we have to be prepared to respond to those as well. And, if you are working in a DevOps organization, you're familiar with that, that it's important that postmortems be blameless. But one of the things that I've seen in different organizations is it's really important to have the right data in order for them to be blameless. Many times I've seen, there's a question between two teams about who is at fault. And of course, we're not trying to blame the teams themselves, but one of the services was not performing correctly, right? And that's, maybe on the client side, they were making the wrong kind of request or making too many requests, or on the server side, maybe they were just being slow. And often teams will have metrics on both sides that show that they're doing the right thing. But by using tracing and looking at a complete end-to-end request, you can kind of tie those things together. So it's not just saying, hey, P50 from the client's perspective was pretty slow, or hey, our latency on the server side looked fine. It's looking at individual requests and understanding, which side actually had an impact, and maybe it was neither side. Maybe it was the network, right? Only tracing can tell you that. Okay, on-call is obviously important. It has direct impact on customer experience. It can affect revenue, reputation, a lot of other things. But I think there's other costs associated with on-call that are a little bit harder to quantify, but still important. And that's the time that your teams are spending handling pages, writing postmortems, handling other kinds of interrupts, because that's time that they're not spending building new features or building or doing proactive optimization or thinking about how to improve reliability in the future. And also, on-call is a major source of stress for a lot of developers. And so in improving that can actually improve their happiness in a lot of ways. And like I said, giving teams the agency to improve things is important through this. But to do that, we also have to understand what their goals are, right? We have to understand what their targets are. And that is the third part of what I wanted to talk about today, service level objectives, or SLOs. SLOs are really just promises that service owners make to their customers. And these can be both internal or external customers, right? They might be end users, or they might just be other teams within the organization. And what's important about SLOs is that they're stated in a way that can be measured, absolutely have to be measured easily, and on short timescales, days, minutes, days, hours, even minutes. And just to give an example, an SLO might look something like this. We've got three parts of that. First, we've got the service level indicator, and that's the metric. That's the thing that we're measuring, in this case, 99th percentile latency. We have a threshold, which is sort of the goal, right? We want to, and it's usually stated as an inequality. We want to keep that latency less than 5 seconds. And finally, we have a measurement window, which I'll talk a bit more about in a second. There might be other kinds of SLIs that are important. You can pick different kinds of latency depending on what you want to optimize for, what your users expect. Error rate might be important. It might also be something like availability, durability, throughput, all might be important, depending on, again, on what your customers expect. So I mentioned measurement window. When we look at graphs that show latency and other metrics, usually those will use a really short measurement window by default, like 10, 30, maybe 60 seconds. And that's good. They should do that. That makes the graphs really responsive. And that's absolutely what you want if you're trying to figure out what's changing in the moment, right? Like if you want to figure out, you just did a rollback and you want to see if, latency got better again, you want to get that measurement as quickly as you can. But instantaneous latency, and again, there's a short window there, but we kind of think of that as instantaneous, is not the right thing for thinking about SLOs. SLOs often are over a little bit longer time periods, often something like 5 minutes, maybe 2 minutes, or even can be longer than that as well. But the idea is that we want to let's give a little bit of smoothing so that we can not make them quite so sensitive to small spikes and things. And because, again, this is not really about like how do we respond to an incident, but how do we measure how well we're doing overall. Okay, how do we determine these things? Well, there's a couple of questions we can ask. We can ask what do our customers expect, right? What promises have we made to them? Maybe we made promises to them in writing, or maybe we just know that if latency increases, that we'll get a drop off in conversion. You should also ask what you can provide today, right? There's no sense in making a promise that you're not going to be able to keep. And you should think about how you can expect that to change, right? Maybe you have a bunch of new features coming out over the next couple of months, and you're not going to have a lot of time to work on reliability. And so maybe you want to back off a little bit on the kind of promise you can make, or maybe you've got time to work on reliability and then go ahead and set that tighter bound. But this is all for external customers, right? For folks that are outside of your organization. What about for internal services? How do we do that? Well, again, this is where distributed tracing is going to be really important. So say we've got this simple architecture here, just these 3 services, A, B, and C. And again, service A maybe serves requests directly to your end users. And so you can set an SLO for that based upon those expectations. So say in this case that we set P99 latency to be, our goal is to have that be less than 5 seconds. Again, over some measurement window, I kind of alighted that here. But what about for B and C? Okay, well, to do that, we're going to have to look at a trace. And actually, we should look at a lot of traces. I'm just throwing in one here just to keep it simple. But from this, we can see that this request to A, mostly that work is done by service B. And service B, in turn, turns around and makes 2 requests to service C. So again, sort of back of the envelope here, this is not being super precise, but we probably want the SLO for service B to be similar. It looks like it needs most of that time since it looks like it's doing the bulk of the work for service A. And so we might set a similar SLO for B to say that P99 latency should be less than 5 seconds. C gets a little more tricky. So we might think, well, there's 2 requests, right? And we got to fit them both in within 5 seconds, right? So maybe this should be 2.5 seconds. That's close. 2.5 seconds is a good place to start, but there's 2 requests here, which not only means they have to be faster, but there's 2 opportunities for C to fail, right? 2 places where it can miss. And so we actually need the latency to be an even tighter bound, not just P99, but P99.5 approximately latency needs to be less than 2.5 seconds. And that's the kind of, that sort of inference we could only make by looking at these kinds of traces, right? Traces also tells us other services that we can't say anything about, right? So it might be that B in some cases also depends on a 4th service, service D in this case, but not in requests that B is serving as part of these requests to A. And so from the point of view of D, what A is providing is actually not useful in this case because D is not part of that trace. Okay, SLOs are important because they are the measure of success in delivering service. And that's great because that's how you can hold teams accountable. But teams can also use them to prioritize work, right? If they know that they've got room in their error budget, if that's a term that you've heard, right? They know that they're doing really well this month in terms of meeting their goal. They can, be a little bit looser, maybe do a few more releases, maybe do a little bit of maintenance that they wouldn't otherwise have done because there might be risks there. But if they know they have the error budget to do it, then that can be a good opportunity for them. And then finally, it's important in how you hold those folks accountable that you do that consistently and transparently across your organization, that you do that in a uniform way. Because really, this is something where these teams are going to look at their peers and they depend on the service of those peers, and they want to know that they're being judged in a similar sort of way. Okay, so to kind of review my sort of 3-piece puzzle here. So, documentation establishes that ownership. That's how you know who is going to be accountable and make sure that everyone knows that, not just engineering leadership, but everyone in the organization needs to understand that. And I think, there's a bunch of ways that we can make documentation more than just static, right? We can use it in a machine readable way to derive configuration, and we can make it dynamic by using telemetry to do that. And that's important because it's important that documentation be up to date and reflect what's happening in production. If it's not going to be useful, and folks are not going to want to invest in it. And they're going to be not confident about doing things like being on call. Like I said, on call is more than just incident response. I think there's a lot of other important parts of that. Writing postmortems is just one of those. And tracing is an important part of not just root cause analysis, which is, I think, where a lot of folks think of using tracing, but as part of building automation, like the example of dynamic alert routing that I gave, or in communicating about what's happening in production. And finally, SLOs, like I said, they're how you measure success. And you can define those internal objectives or objectives for internal services using tracing. Again, you have to know how these services are communicating in order to derive those in a reasonable way. Okay, so that all sounds good. How do we get this thing, right? So, the good news is you're in a DevOps org, and, that affords a lot of autonomy and independence to those teams to make decisions that are appropriate to the work that they're doing. The bad news is it's really hard to make top-down changes, right? I've never seen a tool or process rolled out in a DevOps org top-down. It just doesn't work, or, it times out, right, basically after a couple of years. So to make that work in a bottom-up way, those tools or processes have to provide value to those application developer teams, right? They have to be something that they want to use. And ideally, they're necessary parts of their day-to-day work, right? So, look at the tools that they're using today, look at their workflows and say, what are they using for CI/CD? Can we integrate a new tool, a new process? How does service ownership get reflected in terms of the pipeline? how can we use tracing to make that easier to establish and to maintain? Similarly, where are on-call engineers, finding information? Connecting new information, new tools to that is important. And then to establish and maintain service ownership, like I was saying, I think there's a lot of different pieces to that. What I found in my experience is that documentation, on-call, and SLOs are really important pieces of that. And the one place where you can be a little bit top-down in a way is look at what are critical actions that developers need to take as part of their job, and then in those actions manufacture a need for those tool or processes to make them a necessary part of their work. So the example I gave at Lightstep, you can't make a new service without updating this YAML file because there's no way to deploy it. And so that YAML file is now, that process is now necessary, right? And that's something that'll get used by teams. And then finally, I think, like I said, ownership has more than one piece, and giving teams a budget for improving documentation, for improving alerts, improving reliability is really important. Okay, so to summarize, like I said, ownership, we think of accountability as being the main piece of that, about holding people accountable for their responsibilities, for the goals and deliverables that we set for them, and judging their performance based on that. That's obviously important. But I think the second piece of agency is also really important, giving teams the means, and the means can mean the right information. That could be the right documentation, the right telemetry, the confidence that when they make changes, that those will actually improve things, and the budget as well, right? That could be time or money, but they have a way to do that. And I think what I've tried to state today is that tracing provides key information throughout all of these pieces. Understanding how the system works, taking this holistic point of view, is really key both to accountability and to agency. Just a quick note about Lightstep. So Lightstep, like I said, it's a best-of-breed distributed tracing system. It can help with a lot of these use cases that I've talked about today, and other ones as well. If you want to find out more, you can go to go.lightstep.com/request-a-demo. And with that, I'll pause and we can do some Q&A.
All right, perfect. So just a reminder to the audience to type any questions that you may have for Spoons in the Q&A box now. So our first question is asking, what's the main source of defining SLOs, and can SLIs be defined based on the monitored performance metrics?
Let's see. If I think I understand the question. So let me start with SLIs. Again, it kind of goes back to what your customers expect. So, if you're in e-commerce, then latency, I think, has been shown to be pretty important. If you're in web search, latency has been shown to be pretty important. If you're in, the business of delivering video, maybe throughput's going to be more important. So those metrics are, those performance metrics, I think, are key. I think maybe you can ask a clarifying question if I'm not getting this right, but if you're thinking about the performance of those teams, that can also be a place to define metrics, like how quickly do folks respond to pages. Something like, mean time to action, or mean time to mitigation, or mean time to response, those can be okay. The trick with those things is, like, it's good to set some expectations for those things, I think, but ultimately, like, those things should be derived from your customer obligations, right? So just to take an example, like if you have an availability goal that gives you, say, 3 nines, right? That gives you 42 minutes of downtime a month. If you're gonna, as a developer, wake up, get your laptop out, log in, start looking at some stuff, if you don't, start doing that within 10 minutes, then you're never going to hit that 42-minute thing, because it's going to take you a few minutes to find the problem, a few minutes to roll back whatever it was. So I think if that's if you're getting at, otherwise please ask a clarifying question. And then the source for these, again, like I said, it kind of for SLOs kind of comes from what your customers expect and what your business needs. And so you talk to your customers and see, and talk to your the folks that are supporting those customers and what they're hearing.
All right, this next question is asking, you talked a lot about tracing. What about metrics and logs?
Yeah, great question. So I said the word observability at some point, and I think for a lot of folks, they think of observability as being these kind of three tools that sit side by side. To me, those are really just three data sources, and thinking of them as separate use cases is really not great. So metrics and logs certainly have a role, but I think that role is often much more service specific. So just to take this example, this team I was at Google, where we sat kind of high in the stack. For reasons, we couldn't use Dapper. So we didn't really have a tracing solution. And so what we did was, we get paged and we'd start grepping through logs. And we had a couple of services that our team was responsible for. So we'd start the first one and see which, other service was failing. And then eventually we'd find some other team's service that was failing. But that was just like a lot of very manual grepping, and there's no reasons for humans to really be doing that. So I think of tracing is really providing the structure. It's the kind of like the backbone for this other data. So logs actually can be annotated as part of spans, or you can think about linking out from a trace to find logs via a query or something like that in a log aggregation tool. But I think of traces as a sort of where you start. And then, of course, those other kinds of signals can help explain what's going on, whether it be logs or metrics. But logs and metrics on their own, I think, are never going to be enough unless you have this structure that allows you to understand how the services relate. But good question. Thanks.
All right. Can you talk a bit about OpenTelemetry? Is it more of an alternative to tracing and metric solutions like Zipkin, DropWizard, and Micrometer?
Yeah. So OpenTelemetry is it's an open source project that is part of the Cloud Native Computing Foundation. That's part of the Linux Foundation, and it's a bunch of different pieces. And sorry, I might geek out a little bit on this. From the inside, it's like an API and an SDK and a bunch of different software components. Someone on my team describes it as like a bunch of Legos that you can build pieces of an observability solution out of. And OpenTelemetry handles both tracing data and inform logs and soon metrics as well. But really, from a user's point of view, OpenTelemetry is a way to interface with a system that will collect and analyze telemetry. So you don't need to, say, for example, you don't need to type the word Lightstep into your code, or you don't need to find a Lightstep binding for DropWizard or something like that. OpenTelemetry is really that interface point. And then OpenTelemetry sort of encapsulates a bunch of the common functionality to get that telemetry data out of your application. And then whatever solution or solutions you want to use kind of fit on the other side of that. And so, if you're using something like a framework like DropWizard, OpenTelemetry, you can think of it as it's a plugin for DropWizard that will extract telemetry data from RPCs. Similarly, for other kinds of libraries that you might have. And there was some other piece of that question. Anyway, if I missed something, you can re-ask. But basically, think of OpenTelemetry as a kind of API or SDK for connecting your application with systems that will analyze that telemetry.
All right, perfect. Well, I think that's all the questions that we have for today. Spoons, do you have any closing thoughts that you want to leave the audience with?
No, thanks everybody for your attention. Service ownership is something I care about a lot. I think it's a really important part of the way we at Lightstep work, the way I worked with teams at Google, and I think for a lot of other organizations as well. So if you have other questions or you just want to chat about this stuff, you can find me online. I'm at @save_spoons on Twitter. Thanks.
All right, perfect. Well, thank you so much, Spoons, for being with us today and sharing your expertise with the audience. And also thank you to the audience for attending today's webcast, which was sponsored by Lightstep and presented by adtmag.com. Have a great rest of your day.